Here we have a sad math question. Okay, let's go with the question. 48x negative 72y equals to 30y positive 24 or y equals to 1 over 6 negative 16x. In the given system of equations, r is a constant. If the system has no solution, what is the value for? Usually, actually, we have two linear equations in the given system, and if a system of two linear equations has no solution, then the two lines given by the linear equations in the system must be parallel. So if the two lines are parallel, then their slopes must be equal. And when we solve this kind of problems where we get two linear equations in the system and the system has no solution, we will try to write each equation in slope intercept form so that we can get the slope easily. That is, the slope intercept form is y is equal to mx positive b. So when I write each equation in slope intercept form, I can get the slope easily. So once I get the slopes of the two equations, I can equate them. So because if two lines are parallel, then the slopes must be equal. Since the system has no solution, the equations, the two lines must be parallel with different y-intercepts. Okay, so but here to write each equation in slope intercept form, I have little complication. So because here I find y on both sides of the equation, so first I have to combine the y terms on on only one side of the equation, and also in the second equation, if I want to solve for y, I have to divide both sides by r, and also here I find a fraction. So it's a little complicated to solve for y. That is to write each equation in slope intercept form, that is y equals to mx positive b. So instead of that, we can write each equation in standard form. That is ax positive by equals to c. So this is the equation of a line in standard form. So why should I prefer the standard form? So here we have x term and y term on the left side and the constant on the right side. In the given two equations, I find the constant terms 24 and here 1 over 6 on the right side. So I think I can write each equation in standard form. Okay, so once I write each equation in standard form, I'll be getting the two equations in the form, that is ax positive by equals to, let me consider the constant on the right side over here in the first equation as c1, and the second equation has to be ax positive by is equal to c2, and here we have c1 and then c1 as a constant in the first equation, c2 as constant in the second equation. Both the constants are different. That means c1 and c2 are not equal. Okay, so whenever two lines are parallel and we have the equations in standard form, so like in the standard form of the two equations, the coefficient of x over here, the coefficient of x over here must be same, and the same thing for y, that is the coefficient of y and coefficient of y must be same, but the constant terms the constant we find on the right side must differ. So then we can decide that two lines are parallel and the system has no solution. Okay, so now let's apply the stuff what we have discussed over here for the given two equations. That is, we have to write each equation in standard form. That is, we have to get x term, y term on the left side and constant on the right side. Okay, now let me take the first equation, that is 48x negative 72y equals to 30y positive 24. Okay, so according to the standard form, I must have x term and y term on the left side. Constant must have, we must have the constant on the right side. Okay, already we have constant on the right side. We can keep this 24 on the right side itself. So we have to get rid of this 30y. For that, I have to subtract 30y from both sides. When I do so, this positive 30y and negative 30y will cancel out. I'm getting 48x. When I combine negative 72y and negative 30y, I'm getting negative 102y equals to 24. Okay, now almost I got the equation in standard form, but it can be simplified further because here the number 48, 102, 24. All these numbers have the greatest common divisor 3. So better we can divide each term in this equation by 3 to simplify so that the numbers will become smaller. So let's divide the first term 48x by 3, 102y by 3, 24 by 3. So this 3 goes into 3 one times and 3 goes into 48 16 times. And 3 goes into 3 one times and 3 goes into 102 34 times, and here 3 goes into 3 one times, 3 goes into 24 8 times. So the first equation becomes 16x negative 34y equals to 8. So I got the first equation in standard form over here. So in the same way, I have to get the second equation in standard form. Okay, now let me take the second equation, that is ry equals to 1 over 6 negative 16x. Okay, here already we have the constant on the right side. So the only thing is we have to get the x and y terms on the left side. Already we have y on the left side. So now we have to get rid of this negative 16x. For that, I have to add 16x to both sides. When I add 16x to both sides, this negative 16x positive 16x will cancel out. So on the left side, I'm getting 16x positive ry equals to 1 over 6. Okay, now I got both the equations in standard form. So the first equation in standard form is 16x negative 34y equals to 8, and the second equation in standard form is 16x positive ry equals to 1 over 6. Okay, our aim is to find the value of r. Okay, as we have discussed already, so actually the question says the system has no solution. That means the two lines given over here must be parallel, and if two lines are parallel, then when we write the equations of the two lines in standard form, so they must have the same coefficient of x, same coefficient of y, and different constants on the right side. Already we have the same coefficient for x and different constants on the right side. So the only thing is that the coefficient of y must be same because these two lines are parallel. So if the coefficients of y must be same, then the r, which is the coefficient of y in the second equation, must be equal to the coefficient of y in the first equation, that is negative 34. So now I got the value of r. So the value of r equals to negative 34.